Hello everyone, welcome to the new video lecture of subject Interconnected Power System. Myself Himanshu Joshi. I am an assistant professor in Sri Labhubhai Trivedi Institute of Engineering and Technology, Rajkot. So till now we have covered about the topic of formation of Y bus. So how to formate the Y bus, what are the modification in case of Y bus. So now our today's topic is formation of Z bus, or it is famously known as Z bus building algorithm. So in this video lecture we are going to discuss about the formation of Z bus, that means how to build the Z bus from the given network. So we can say that Z bus building algorithm is a step by step programmable technique which proceeds branch by branch, and it has the advantage that any modification of network does not require the complete rebuilding of Z bus. So there are various modification in which we are going to just modify the part in which the changes will occur. We do not require complete rebuilding of Z bus. So we can say that Z bus has been formulated up to a certain stage and another branch is now added. For example that we have already covered a Z bus. We have already built Z bus, and if at certain stage another branch is added, then we can say that if we are having a Z bus old and if branch impedance ZB is added in existing system, then we are having a new Z bus. Then we are having a one new Z bus. So upon adding a new branch, various kinds of situation will be presented based on where that branch is added. So we can say that ZB is added between new bus to reference bus. For example, a branch ZB is added between new bus to reference bus. So in that case, new branch is added in case of new bus. So we can say that one extra bus is added in existing system. So in that case, the modification is look like that dimension of Z bus is increased by 1 because new bus is added. So that kind of modification we are going to say is type 1 modification. Now second case, ZB is added between new bus to old bus. So again in that case, new bus will be added to existing system. So again in that particular case, the dimension of Z bus is increased by 1, and it is known as type 2 modification. Now third opportunity is ZB is added to old bus to reference bus, old to reference. Now in that case, no new buses is added in our existing system. So it is look like the modification of existing system, no new bus will be added. So in that case, the dimension of Z bus is does not change, and we will say this type of modification about type 3 modification. Now fourth modification is ZB branch impedance is added between two old bus. So again this is the case of existing system. So in that case also Z bus will remain same, and it is known as type 4 modification. This is known as type 4 modification. Last but not least, if ZB is added between two new bus, but this situation we are going to avoid, because by means of proper planning we do not required to add two new bus at a time. Clear? By means of proper system planning we do not required to add two new bus at a time. So this situation we are going to avoid, and now onwards we will ignore such kind of modification, though it's our type 5 modification, but we do not consider this type of modification, because if we do the proper planning of system then we do not require to add two new bus at a time. So this we are going to ignore. So in our system we are having only 4 type of modification, in which first case ZB is added between new bus to reference bus, type 1 modification. Over here new bus, so dimension will increase by 1. Type 2 modification, in which ZB is added between new bus to old bus, again new bus comes in picture, so dimension will increase by 1. It's our type 2 modification. In case of type 3 modification, ZB is added between old bus to reference bus, again over here no new buses, so dimension will not going to change, and it's our type 3 modification. Again in case of fourth modification, ZB is added between two old bus, so no new bus will be added to the system, so dimension will remain same, and this is our type 4 modification. Type 5 we are not going to consider. By means of proper planning we do not require to add two new buses at a time. So these are the 4 type of modification which we required for the Z bus building algorithm. Now in this particular topic we are going to use a notation in which I and J denotes the old buses. I and J notification will denotes the old buses. R denotes the reference bus and suffix K denotes the new bus. So suffix I and J used for old buses, suffix R used for reference bus, suffix K used for new buses. So these are the notification notation we are going to use for our particular topic. Now let's start with the type 1 modification. So we know that in case of type 1 modification, ZB is added between new bus to reference bus, and ZB is the branch impedance, and new buses will be added to the system. So we can say that dimension of Z bus will increase by 1, and it's our type 1 modification. So over here let's consider we are having a n bus network, passive linear n bus network. So 1 to n and I to j are our old buses. Let's suppose branch impedance ZB is added between new bus to our reference bus. Bus number K is our new bus, R is our reference bus. ZB is added between this K bus to R bus, and suppose that voltage between K bus to reference bus is Vk and branch current is Ik. Branch current is Ik. So we can say that Vk is equal to ZB into Ik. Vk is equal to ZB into Ik, and from K the another impedances are 0. That means Zki is equal to Zik is equal to 0, where I is equal to 0 to n, because only ZB is added from bus number K. So rest of the impedances are 0. Rest of the impedances are 0. That means entries is equal to 0. No entries will be added except only single ZB into IK. So, K bus impedance, self impedance of K bus, that means ZKK is equal to ZB. So, this is the only modification in upcoming new Z bus. So, let us suppose how to add this modification in existing bus. So, let us suppose this is our old bus. This is our old bus starting from Z11 to Z1n, and in case of vertical Zn1 to Znn, that we already know. Okay, now new buses will be added. So, we have to add one row and one column. One row and one column in new Z bus matrix. So, the entry in case of new Z bus is only ZB, only ZB. So, we can say that rest of the elements we have to put equal to 0, and the last element, that is equal to ZKK, is equal to ZB. ZKK is equal to ZB. So, we can say that if new branch will be added between new bus to reference bus, then only self impedance of that bus will be the entry in new row and new column. So, this is known as type 1 modification. Now, let us consider about the type 2 modification. So, in case of type 2 modification is that ZB is added between new bus to old bus, new bus to old bus. So, if new buses will be added, then dimension of Z bus will be increased by 1, and this is our type 2 modification. This is our type 2 modification. So, over here let consider J bus is our old bus, J bus is our old bus, and K bus is our new bus, and ZB branch is added between old bus to new bus. So, this is our ZB which is added between this old bus to new bus. So, suppose K branch current is already we know that which is equal to IK, K branch current is IK, and J branch current is IJ. So, if new branch will be added, then this current will get changed by IJ plus IK. As per Kirchhoff's current law, KCL, we can say that if new branch will be added, then the current injecting into the system will modified by IJ plus IK. Previous current is IJ, new current is IJ plus IK. And if we add the ZB between old bus to new bus, then this loop will form. This loop will form. And let consider that K bus voltage is Vk and J bus voltage is Vj. So, if we apply the Kirchhoff voltage law in this existing loop which formed by Vk, Zb and Vj, then I can write that Vk is equal to Zb into Ik plus Vj. Vk is equal to Zb into Ik plus Vj. Vk is equal to Zb into Ik plus Vj. So, now let us put the value of Vj. So, Vk is equal to Zb into Ik plus Vj. I can write the equation for Vj is Zj1 into I1 plus Zj2 into I2 plus up to Zjj into Ij plus Ik plus up to Zjn into In. Now you can observe that in case of Zjj I have written over here Ij plus Ik just because modified current of J bus is not only Ij but it is equal to Ij plus Ik, and that is why I have written over here Zjj into Ij plus Ik. So now in next step we will multiply Zjj with Ij and Ik. So the multiplication will look like this: Zjj into Ij plus Zjj into Ik. Now let's write from starting from 1. So first of all I will write Zj1 into I1, next I will write Zj2 into I2, next I will write Zjj into Ij, and I will write Zjn into In. In last I will write equation for new bus. So there are two terms for new bus, that is Zjj into Ik and Zb into Ik. So in last I will write Zjj into Ik plus Zb into Ik. Now from these two term I will keep Ik common. So final equation for Vk will look like this: Vk is equal to Zj1 into I1 plus Zj2 into I2 plus Zjj into Ij plus Zjn into In plus, after taking common Ik, equation becomes Zjj plus Zb into Ik. So this is the row that will added in our new Z bus equation. This is the row, or you can say that this is the column that will added in our new Z bus matrix. So new Z bus will look like this. This is our Z bus old. So one row and one column will be added because new node is generated due to new bus. So in row we have to write Zj1, Zj2, Zjj up to Zjn. So this is the row, and similarly this is the column, and this is our K bus element or impedance Zjj plus Zb. So this is the type 2 modification in which new bus is added between new to old. So this is our type 2 modification, and this is the new row and new column that will be added due to new bus, which is equal to K bus. Now consider the type 3 modification. So in case of type 3 modification, Zb is added between Zb is added between old bus and reference bus. So you can say that new buses is not added into the system. So matrix dimension does not going to change, only a loop is formed, and it is known as type 3 modification. So we can say that suppose Zb is added between old bus to reference bus, and suppose that current is Ik. So we can say that Zb connects to old bus to reference bus, and this case follows from connecting K bus to reference bus by setting Vk equal to 0. Now this is the case. You can see over here that suppose okay, now suppose if I will connect this K bus to reference bus by short circuiting this voltage Vk. Suppose I will short circuit this K bus by connecting with reference, then you can see that now this ZB is get connects between old bus to reference bus. Let me clarify you. Okay, in case of type 3 modification, we are going to connect a branch ZB between old bus to reference bus. Now this case is similar to type 2 modification. If we are going to short circuit this K bus by connecting this K bus to reference bus and by keep Vk equal to 0. So if we are going to short circuit this branch, then you can see over here that this J bus is connected to reference bus by means of ZB. Clear? So we will use this concept in our type 3 modification, and that's why I have written over here that this case follows from connecting bus K to reference bus by setting Vk equal to 0. Clear? So we are going to use the concept of type 2 modification in type 3 modification. So over here this is our basic matrix V is equal to I into Z, in which we are going to keep Vk equal to 0. We are going to keep, or we are going to set Vk equal to 0. So by means of this matrix we are going to write equation of Vk. So over here Vk is equal to 0. So this Zj1 multiply with I1, J2 multiply with I2, Jn multiply with In, and last Zjj plus Zb multiply with Ik. So this is the equation that we have written from this particular matrix. Now let me keep Ik on left hand side and remaining term on right hand side. So you can observe over here that if I will write Ik only on left hand side, then this remaining term will get negative. So this is the minus sign, and these are the term that we have written based on the equation. And this Zjj plus Zb, which is multiplied over here, it will be divided over here. So final equation of Ik will look like this: minus 1 upon Zjj plus Zb multiply by Zj1 into I1 plus Zj2 into I2 plus up to Zjj into Ij plus Zjn into In. Now similarly we can write equation for ith bus, and it is again same: Zi1 into I1 plus Zi2 into I2 plus Zin into In plus Zij into Ik. So this is the equation for old bus, which is equal to I. So now what we are going to do, we will put the value of Ik over here. So the new equation will become, and it will look like this. This is the equation up to In. This is the Ij, which I have written over here. Now Ij is multiplied with Ik. So Ik will be replaced by this equation that we have derived. This entire equation we are going to put in place of Ik. So this is the equation of Ik. So now we have to modify this equation to find out the value of Vi. So over here you can observe that I1 and I1. So what I will do, I will keep I1 as common. So if I will take I1 common from over here, then Zi1 will remain. and again if I will take I1 common, then the remaining term over here is Zij into Zj1 divided by Zjj plus Zb, because this Ij is multiplied with entire bracket. So, if I will take I1 common, Zij will appear. Again I1 is multiplication with Zj1, so Zj1 will multiply with this Zij, and again this Zjj plus Zb is divided by this entire equation, so it will also divide with I1, and that is why Zjj plus Zb comes in denominator. So, if I will take I1 common, then equation Vi will become Vi is equal to Zi1 minus 1 upon Zjj plus Zb into Zij into Zj1 multiply with I1. Similarly, if I will take I2 common, then the remaining bracket I can write directly from this. And that bracket is Zi2 minus 1 upon Zjj plus Zb into Zij into Zj2. Similarly, I can write for In. The bracket is Zin minus 1 upon Zjj plus Zb into Zij into Zjn multiply with In. So, this is the equation for ith bus. So, from this I can write Z bus new, because this Z bus new I can write directly from this equation, because suppose that let me write Z bus new. So, this I1, Zi1, Zi2 up to Zin, these are the elements of old bus. And over here you can see directly that this multiplying factor 1 upon Zjj plus Zb is common for all, that means up to nth term. So, I can write, and this is minus, this term is minus. So, over here I will write minus 1 upon Zjj plus Zb. The changing term is only Zj1, Zj2 up to Zjn. So, that I will represent by means of row and colon, Zj1, Zj2 up to Zjn and Z1j, Z2j up to Znj. So, this is the type 3 modification. This is our type 3 modification that we can write based on old bus equation. Now, last type 4 modification. So, in case of type 4 modification, Zb is added between two old bus. So, again dimension will remain same, and this is our last and type 4 modification. So, let us consider two old bus, bus number I and bus number j. Branch added is Zb and branch current is Ik. So, over here you can see that by means of direction of Ik, I can say that the current injecting into the bus will become I plus Ik, and as direction of current is outward from this node, the current of J bus is Ij minus Ik. Clear? Based on the direction I can write the bus current of I bus and J bus, because direction of Ik is this current will modified by I plus Ik, and direction of Ik is downward direction. So, J bus current is Ij minus Ik. So, let me write the equation of bus, I bus. So, ith bus equation will look like this: Vi is equal to Zi1 into I1 plus Zi2 into I2 plus Zii. Now, ith bus current is Ii plus Ik. So, Zii into Ii plus Ik plus Zij. Now, J bus current is ij minus ik. So Zij into ij minus ik plus up to Zin into in. Clear? So this is the equation of ith bus. Now for j bus I can write KVL equation. Vj is equal to Zb into Ik plus Vi. Vj is equal to Zb into Ik plus Vi. Now what we will do? We will put the Vi equation over here. We are going to put the Vi equation over here. So I can write Vj is equal to Zb into Ik, and this is the entire equation of Vi. So now to find out the modification in existing Z bus, we have to put value of Vj also. Clear? So this entire big bracket I have written the equation of Vj and Vi. So the progress will look like this. This is the equation of Vj, which represents by Vj. This is the sign of equal to, this is the sign of equal to, and this is the rest of the equation. So for Vj or J bus, I can write Zj1 into I1 plus Zj2 into I2 plus up to Zji. So for the ith bus, current is II plus Ik. So Zji into II plus Ik plus Zjj. That means for J bus current is Ij minus Ik. So Zjj into Ij minus Ik plus up to Zjn into In is equal to Zb into Ik plus the equation of Vi that we have already written over here. So this is the final equation in which we are going to simplify and find the modification in Z bus. So now what I will do, I will shift this entire equation in left hand side. I will shift this entire equation, in right hand side. I will shift this entire equation in right hand side. So over here left hand side will equal to 0 because I will shift this entire side in right hand side. So in left hand side only 0 will remaining, and right hand side what are the modification? Let me show you. So this is equal to 0 and this is the existing right hand side of equal to. So this is the same, this will remain same. Now these all terms are positive in left hand side. So if I will shift in right hand side, all terms becomes negative. So this is the minus Zj1 I1 minus Zj2 I2 minus Zji into II plus Ik minus Zjj into Ij minus Ik minus up to minus Zjn In. These all are positive in our left hand side. So all becomes negative in right hand side. Clear? So this will be the change if I will shift entire equation in right hand side. Now over here you can observe that this is the I1 term. So if I will take I1 common, so I will take I1 common, so remaining term in bracket will be Zi1 minus Zj1. Similarly for I2, if I will take I2, then remaining term in bracket will be Zi2 minus Zj2. Now let me talk about current II. So II current you can find in two terms. Clear? So if I will take II common, then the remaining term in bracket will be Zii minus Zji. Clear? Again let me talk about current Ij. So Ij you can find Ij over here and over here. So ij, if I will take ij common, the remaining term in bracket will be zij minus zjj. Over here zij plus zjj minus. So remaining term in bracket will be zij minus zjj. Similarly for in, in is over here and over here. So plus zin minus zjn will comes in bracket if I will take in as a common. So over here is in, remaining term in bracket will be zin minus zjn. Now let us talk about the current Ik. There are slightly changes in case of Ik. Ik you can find in so many terms. Over here is Ik, over here is Ik which is multiply with Zii, over here is minus Ik, again this is Ik multiply with minus Zji, and over here is minus Ik multiply with minus Zjj. So if I will take Ik common from this 1, 2, 3, 4 and 5 terms, then the remaining terms in bracket will be look like this. Suppose I will take Ik common from over here, so remaining term in bracket is Zb. Again I will take Ik common from over here, remaining term will be Zii. So I will write Zii. Again I will take plus Ik common, so this minus sign I have to multiply with Zij. So this is Zij. Again I will take plus Ik common over here, so this remaining term will be minus Zji. Again I will take Ik common, but over here minus minus will become plus, so remaining term will be plus Zjj. Clear? So this is the modified step over here. Clear? This is the modified step that I will take from here. So now this is the final term. Now you can observe over here that I can replace this Zij and Zji by adding each other, because you can say that Z12 is equal to Z21. Clear? So similar case over here, this is Zij, this is Zji, and both are minus, so I can add them and it will become minus 2Zij. So this is the final equation. This is the final equation. So modification in Z bus, you can see over here that this is our Z bus old. Again modification comes look like this: Zi1 minus Zj1, Zii minus Ji, again Ij minus Jj, similarly In minus Jn. So in case of row, modification will look like this: Zi1 minus Zj1 up to Zin minus Zjn. Similarly for column, Z1i minus 1j, Z2i minus 2j up to Zni minus nj. The remaining or the main changes in case of this: Zb plus Zii plus Zjj minus 2Zij. Clear? So this is our modification in existing bus, but keep note down that there is no new row and new column, nothing look like that. There is a change in case of row and column in J bus, in case of jth bus. So in case by means of formula we can write that Z bus new or modified bus is equal to Z bus old minus 1 upon Zb plus Zii plus Zjj minus 2Zij multiply with 1i minus 1j, Z2i minus 2j up to Zni minus nj, multiply with similar row Zi1 minus Zj1, Zi2 minus Zj2 up to Zin minus Zjn. This we can derive if we will keep ik on left hand side, remaining term on right hand side. So, this is the final modification, type 4 modification. This is the formula for find out the modification in existing Z bus matrix. So, these are the all type 4 modification, and it is one of the very much important topic in case of winter 2020 exam. So, with this we will conclude our session. Thank you very much. If you like my video, then please like it, share with your friends, and if you have not subscribed my YouTube channel, then please subscribe my YouTube channel Himanshu Joshi. Thank you very much.